So yeah, today, as Lou said, I'm going to talk about the dialogical account of deduction in relation to the axiomatic method specifically. So I've got a little summary because I didn't know which order the talks would be in when I wrote it. But in the dialogical roots of deduction, Katerina has given us a very novel account of deduction as being a kind of essentially dialogical notion. I think one feature that we'll have all noticed if you've read the book is that it's remarkably wide-ranging. It covers history, philosophy, psychology. But because I don't know much about many of those things, I'm going to focus in on a fairly narrow issue regarding mathematical proof. So I want to distinguish between two functions that proofs have in mathematics. No claim that it's an exhaustive distinction or anything. And I want to argue that the dialogical account of deduction seems to offer an explanation of just one of them, arguably the more important one. But nonetheless, so the function that I think is not obviously explained by the dialogical account is pretty central to the axiomatic method and the role of proof in axiomatic mathematics. So really, this is actually just a half an hour long way of me asking Katerina to write another paper for us to read. But that's the general shape of today. So Katerina has argued that the basic features of the practice of producing and consuming mathematical proofs are reflected in the prover-skeptic dialogue. So I think I'll just skip over this part of the talk because we've already heard what those are. So we've got the dialogue between prover and skeptic, and we're familiar with how that works now. So one thing that's sort of not been mentioned yet today, I don't think, is the kind of explanatory work that this account does in the book. So deduction has a number of features which are kind of very nicely explained by this prover-skeptic model. So one of them is necessary truth preservation. Right? So of course we want a successful deduction to be such that it follows necessarily from the truth of the premises that the conclusion is true. So I think Katerina's got a really nice explanation of why we want deduction to have this feature. And so we're not just trying to persuade anyone. We're particularly trying to persuade a skeptic who's not going to accept anything unless they have to. Proofs, of course, as we know, also have to be perspicuous, or at least they should be perspicuous. So not only are these dialogues sort of semi-adversarial, they're also cooperative in a way that I think Matthew Inglis gave a very nice account of. And so, and indeed, we saw in several examples from Timothy Gower's talk, the prover and the skeptic are sort of cooperating to come up with something, whatever you happen to get out of the dialogue. So it's not just enough to have any old truth-preserving argument, necessary truth-preserving argument. It needs to be a clear one that's communicable to other people. And the other slightly odd feature of deduction that's discussed here is belief bracketing. So in a dialogue, you don't just draw consequences from your own discursive commitment, but also the discursive commitments of your interlocutors. Right? So this is why deduction is often sort of hypothetical, right? You make deductions from premises that you don't believe, or you make deductions from premises that you explicitly don't believe, like when you're doing a reductio or something like that. So one thing that I think is really nice about the book is that Katerina makes the case that these are all quite odd features that really do need an explanation. And these aren't the sort of things we can take for granted. So in all of the sort of psychology chapters, we see that humans require quite a lot of training to make deductive inferences well. It's not something that people seem very naturally suited to. And they're cognitively very costly, bracketing beliefs and worrying about every possible counterexample and things like that. So deductive arguments are quite strange in these ways, and I think we get a very nice explanation in the book in terms of the prover-skeptic dialogues as to why deduction and proof in mathematics particularly has these features. But I think that when we're assessing this account, it's quite common to think of just one of the many things that you can do with a mathematical proof, but arguably the most important one, which is just to persuade somebody that something is true. So this is the basic setup of the prover-skeptic dialogue. As we've heard, the skeptic is often internalized, so it's often yourself. You're trying to persuade somebody, including yourself, that something is true. And I think for the reasons, well, broadly for the reasons that are just given in the book, I think where proofs are doing, carrying out this persuasive function, the dialogical account gives us a very nice picture of how that's working. So I think this is a pretty major achievement, and I'm sure people are going to be talking and writing about this for a long time. But not all kinds of proofs in mathematics have this function of trying to persuade somebody that something is true. And I would like to sort of hear a bit more about how proofs like those work. So Katerina discusses a number of other functions that proofs have. So one that she discusses is systematizing. So this isn't the second big kind of proofs that I want to talk about today. This is just a warm-up. So systematizing is maybe a less central part of proof, certainly less central than just persuading somebody that something is true. And as this is described in the book, proofs are systematizing when they expose connections between different mathematical concepts, or when they provide an argument pattern that's useful in multiple proofs, sort of across disparate areas. So the kinds of strategies that are repeated in distinct areas of mathematics. And to her credit, Katerina admits that the dialogical account doesn't have a sort of ready explanation of this function of proofs. So the dialogical account gives a local perspective, right, which is, I take it means that it's aiming to explain why individual proofs have the features that they have, but not necessarily to explain the sort of relationship between distinct proofs, which is what systematizing does. So I want to pick up on a different function that proofs have, which I think is like systematizing, and I would have liked to have used the name systematizing, but that's been taken. So I'm going to instead just call it organizing. I think it's like systematizing, it's more general and it's more significant, and it relates importantly to the axiomatic method. And I think for somewhat similar reasons, it's one that I can't see a ready explanation of in dialogical terms. Although that, of course, could just be lack of imagination on my part. So I'll tell you a little bit more about what this is. So this is broadly, the organizing function of a proof, right, is just to illuminate the logical or the inferential connections between different propositions. So when you've got a proof, you don't just prove that the conclusion is true, you also establish various inferential facts. So for example, that the conclusion follows from the particular premises that features in the proof, and that it follows by using particular deductive moves and things like that. And so you're not just getting information about what's true and what's not. And of course, in a lot of proofs, you might not even believe the premises. And if the premises aren't conclusively established, then the proof won't even be in a very good position to persuade anybody that its conclusion is true. But it will still be in a very good position to prove lots of things about the inferential connections between the propositions. So it's not just this that I mean by organizing that. So more generically, proofs can be used to establish independence, consistency, logical equivalence, just various facts about the relationship between propositions. And this is a function of proofs which I will outline why I at least think that more needs to be said from the dialogical account to really give us a satisfying explanation here. So call this organizing, terminology borrowed from Russell. And my main contentions are that this function is just qualifies as a basic feature of the practice of producing and consuming mathematical proofs, and that it's not readily explained in dialogical terms, or at least not as readily explained as the sort of persuasive function, which I think is, as I said, is given an extremely satisfying explanation. So to kind of bring out the problem, I'm going to talk largely about axiomatic mathematics. So in axiomatic mathematics, we have, well, at least one thing, a significant chunk of mathematics presented as the deductive consequences of some selected set of axioms or first principles or premises. And the organizing function of proofs takes pride of place here. So I should say also, just to ward off anything, I'm not thinking of anything necessarily as formal, and the axioms can be informal, and the consequence relation in question needn't be logical. We'll see that in an example in a moment. But I think an important point about the history of the subject is that axiomatic mathematics has been really highly thought of for as long as it's been around. Right? So from ancient Greece to the present day, axiomatic mathematics is thought to be kind of highest standard of rigor and proper methodology for mathematicians to be doing. And indeed, for a very long period of time, it wasn't just thought to be the proper methodology for maths, it was thought to be the proper methodology for everybody. People doing axiomatic presentations of things like medicine and theology and all sorts of things that have kind of fallen out of fashion. But nonetheless, this has been a sort of big deal since it started. I think one of the reasons why the axiomatic method is so valuable is precisely because its proofs do so much organizing. So an axiomatic theory sheds so much light on the logical relations between propositions because you find out that they all follow from some very small, or not always small, but sometimes even infinitely many, but some well-delineated set of starting points. So, I mean, this is a bit idealistic, and I'm not necessarily endorsing it, right? But if the axiomatic method goes well, it's completely explicit what the assumptions of all your proofs in an entire field of knowledge are. The proofs don't have any gaps, right? It's kind of explicit what inferences are allowed, and the inferences in an axiomatic presentation of a theory all conform to those. So, and I'm not claiming at all that this is a one-size-fits-all approach. The standards for what counts as proper rigor have changed over time, and that's all fine. But this style of mathematics has been extremely important for a long time, and I want to suggest that it's largely to do with organization. So to illustrate why I think this side of mathematics doesn't necessarily go so smoothly with the dialogical account, I want to think about Euclid's Elements as a case study. So there's lots of different things that I think you could pick here, but importantly, the Elements is a work of ancient Greek mathematics. It dates from about 300 BCE, and it arises in the intellectual context that Katerina sort of identifies as the dialogical roots of, as giving rise to the general practice of deductive arguments. So this is ancient Greek. Also important to note is that Euclid's Elements was not an unrepresentative one-off. This kind of thinking was a very important part of ancient Greek mathematics more generally. So Hippocrates of Chios, Leon, and Theudius of Magnesia all gave axiomatic presentations of mathematical theories before Euclid did, although sadly all three of those are completely lost. But this is just an important part of the practice of ancient Greek mathematics where these sort of practices that Katerina discusses in the book are appearing. So I'm going to argue that in the Elements in particular, although my hope is that this generalizes a bit, the organizing function of proofs is of central importance, so that it should qualify as a kind of basic part of the practice of producing and consuming proofs. Now, we're not just thinking of this general practice of making mathematical proofs as being about convincing people that things are true, though that's definitely an important part of it. It's also about illuminating the logical relationships that hold between various mathematical propositions. So the Elements is of canonical importance for millennia after its publication. And I think we can see that just the organizing function of proofs without really any thought of persuasion is an important part of this by considering the fact that it's basically a textbook. Right? So a lot of the stuff that Euclid proves was already known, right? And it's Euclid's just giving a more systematic presentation of various things. And some of the things that Euclid bothers to prove are even more obvious than some of the postulates. So, for example, Euclid proves that the sum of two sides of a triangle is greater than the length of the third side. And well, if that wasn't true, the triangle just wouldn't join up. So it seems kind of totally obvious. And we'll look at one of the postulates that's maybe less obvious than that in a moment. But the Elements is been described as the most successful textbook of all time. And I think that's probably right. So I want to suggest that where we've got these proofs in Euclid of various known propositions, the value of the proof is primarily organizational. Right? There's no, you're not trying to convince anybody, probably including yourself, of the truth of these propositions. Right? You primarily just want to see their relation to the axioms. And I think importantly as well, these organizational proofs, they have all the same cognitively strenuous features that Katerina identifies. In particular, necessary truth preservation. So all of the praise that gets heaped on Euclid over the many hundreds of years since publication typically relates to the sort of rigor of the proofs, and even as late as the 30s, you've got Einstein saying things like, well, not one proposition in that book admits of the slightest doubt. A dubious claim, I think, but who am I to argue with Einstein? So it's these proofs are not, they're not sort of lower grade than persuasive proofs. They have all the same features, and I think I've bought Katerina's argument that those features need explaining, but I don't see how the semi-adversarial proof-of-skeptic dialogues does offer an explanation of why proofs that primarily are organizational should have these kind of cognitively odd features. So a possible kind of quick fix that I've been thinking about, which you might offer on behalf of the dialogical account, relates back to this point that I made a few minutes ago. So a proof of proposition is also proof that the proposition follows from the particular premises. So I put in a that to emphasize that this is itself a proposition, and maybe this is the sort of thing that you need to convince skeptic of. Right? So maybe skeptic doesn't need to be convinced, say, that the sum of two sides of a triangle is greater than the third. What they need to be convinced of is that there's a proof of this from the axioms. And if so, then we can give a dialogical account of that, because that's performing a persuasive function, and it's all fine again. And this is, I essentially see this as a strategy for sort of just denying that Euclid's proofs of known results are primarily of organizational value. So I think this is definitely going to be a correct account of a lot of proofs, right? So particularly thinking about more sort of modern axiomatic mathematics, people really care about sort of what follows from various assumptions in set theory that they don't believe, for instance. So there are definitely going to be lots of proofs where this is the right thing to say, and a proof that's, you might initially mistake for one that's primarily playing an organizing role is really playing a persuasive role, but it's just persuading you of the sort of meta theorem. But I think this strategy isn't available in all cases, and I think there are some important cases where this kind of account doesn't seem to me, at least, to work. So the case I want to discuss is the parallel postulate. So just in case anyone's not clear, we're back to Euclid now, and the parallel postulate tells you that if you have two lines that are intersected by a segment, and on one side of that the internal angles are less than 180 degrees, then if continued indefinitely, the lines will cross on this side. So the parallel postulate was a big deal from ancient times until it was shown to be independent centuries later. So Euclid's readers typically thought that the parallel postulate wasn't really obvious enough to be a postulate, right? It seems to be the sort of thing that needed a proof. And you can, interestingly, Euclid does bother to prove the converse of the parallel postulate, so that if two lines meet on a side and then you intersect at the segment, you have the angle sizes less than 180 degrees in total. But nobody managed to prove it. So as late as 1767, you've got D'Alembert describing the lack of a proof as the scandal of elementary geometry. And it was finally shown to be independent of the other four postulates. And Hilbert in 1899 described this as one of the most important results of geometrical inquiries. So I'm sure many of you will be familiar with this kind of story already. So Euclid's commentators all agreed that the parallel postulate was true. Proclus is one of the most prominent ancient commentators on Euclid. Euclid described it as obvious that the parallel postulate was true. So just to recapitulate the kind of quick fix strategy I'm thinking about here, the proposal would be, we can give a dialogical explanation for what's going on here, because there is a fact that we need to persuade people's truth of. That fact isn't the truth of the parallel postulate, it's its theoremhood with relation to the other axioms. So I think what's kind of interesting about this story is that not only did all of Euclid's commentators agree that the parallel postulate was true, they agreed that it was a theorem anyway. They just wanted to see a very specific proof that could be found. So Florence Lewis identifies the first doubts about the parallel postulate's theoremhood to a paper by Klugel from 1763, where Klugel goes through, I think it's 30 alleged proofs of the parallel postulate, shows that they're all fallacious, and then the paper sort of ends with, oh, what if it's not a theorem? And that's, as far as I'm aware, that's the first kind of serious doubt that anyone's raised about it. So this sort of means that, or at least it seems to me, that we've got the situation for about 2,000 years of people very strenuously trying to come up with a proof of something they already believe to be true, and that they already believe to be a theorem. Doesn't seem an obvious skeptic to persuade, but they just want to sort of see what inferential moves have to be used to get from the axioms to the parallel postulate. Of course, no such moves exist, but they didn't know that. So I don't think the quick fix explanation I proposed really applies here. So Proclus describes the problem with the parallel postulate as its obvious character does not appear independently of demonstration, and then I think the quote continues by saying something like, but is transformed by proof into a matter of knowledge. So the idea, I take it, is that the logical relation to the axioms isn't properly exhibited, according to Proclus, in Euclid's original presentation. Right? Euclid has 5 postulates. Proclus thinks he could have got away with having 4. And there must be a proof of the parallel postulate from the others. Everybody agrees that, and where Euclid went wrong was by misrepresenting the logical relations between the propositions. But I can't, at least, I mean, maybe, as I said, just a lack of imagination, perhaps, but I can't see why the importance of this kind of thing how it can be explained in dialogical terms, or why an argument kind of settling it would need the cognitively strenuous features that are explained by the dialogical account. Why, people already thought there was a proof somewhere out in the ether, so why wouldn't some sort of plausibility argument work or something? Why is it really a proof that we need? So I take it here that, I'm sort of thinking of Katharina as a bit of a victim of her own success. It's got a really persuasive argument as to why proofs are kind of odd in certain ways, why it's strange that we do them, and then an explanation of why we do them. But I think there are some cases where we do them, and people indeed did them for about 2,000 years, that the dialogical account doesn't obviously explain. So I've got a couple of minutes just to sum up. So I think the sort of organizing role of proofs at the exhibiting of the logical relations between propositions, this is a central part of the axiomatic method, a central part of why people think it's good. And it originates in the same intellectual context that Katharina pins as the origins of the practice of deduction that we're talking about. So I think this qualifies as a basic feature of the practice of producing and consuming mathematical proofs, right? Producing proofs that have this organizing function. Some of them, of course, also serve to persuade people that something's true, but some of them seem to primarily or even exclusively have this organizing purpose. And this is something that's been going on for as long as the sort of deductive practices that we're talking about. But the semi-adversarial nature of the prover-skeptic dialogues, I can't see how there's an explanation in those terms of why we have all of these particularly cognitively strenuous features when there's no skeptic to persuade. So I want to basically suggest that I think Katharina's done an excellent job of explaining the persuasive function of proofs, which I'll admit is probably the most important one. But I think this would be a highly influential account, and people will be talking about it for a long time. And one thing that I'd like them to talk about a bit more is how this account of mathematical proof fits in with the kind of proofs that you see at large in the axiomatic method. So yeah, I think that's about 25 minutes or something. So that's me done. Thank you.